Today we're in section 8.2, linear equations and two variables. We talked on Friday that linear equations, what does linear mean? What does linear mean? It's a line, okay? Linear is a line, so what do we expect to see when we graph these equations? A straight line. If it's zigzag, we know we did something wrong. It needs to be a straight line when I'm graphing these linear equations. All right, now in example 1, we're checking solutions. So we're checking to see if the ordered pair is a solution to the equation. We plug in our x and our y values in for x and y in the original equation. All right, so 2 times 9 minus 13 equals 5. Well, what's 18 minus 13? 5 equals 5. Yes, this is a solution. This is what I want to see on your homework tonight. All right, is the ordered pair, your substitution, and your boxed answer. All right, now the equation is part of your directions. I'm not going to be picky if I don't actually see the equation, but I have to see the substitution, and then your boxed answer showing that both sides either equal or don't equal. On the second one, 2 times 4, here's the catch on the second one. The subtraction sign is in the original equation. So what happens when I plug in negative and also? Changes to a positive. So now 8 plus 7 is what? 15. 15 does not equal 5. No. Well, if you forget to change your double negative, 8 minus 7 is still 1 and it does not equal. So technically you would get the answer right, but you would still get it marked wrong because you didn't do the operations correctly. So make sure you catch those double negatives. So example 1 is just checking solutions. In example 2, and please guys, don't overthink this, all right? You know, I have my 6 hour, they really get hung up on this volcano example. Here's what it's trying to lay the groundwork for and trying to teach you, is that we use input and output values to predict a pattern so that we can tell the future, basically. All right, so in this volcano example, how many miles is it away from the ocean? 32 miles. Here's what it's asking us. If it's 32 miles away from the ocean, how long is it going to take for that lava to reach the ocean? That's all it wants us to solve for. Well, we need an equation. It gives us that. You're not going to use this equation on any other problem except the volcano problem that we're about to solve. It's not a formula that you have to memorize. It's just part of this problem. You with me? Okay. So in order to solve this, though, and this is the same with graphing equations, we've got to have input values. So we're just going to make them up. Now, would I plug in like 50 hours? Well, no, that doesn't make sense because I don't think it's really going to take 50 hours in the first place, so I don't want a negative. All I want is values that can help me see the pattern with my distance. I've got to be able to see the pattern. How far is it traveling per hour? So if I plug in, like I said, I made up these values. If I plug in 1 hour for t, what's 4 times 1? 4. What's 32 minus 4? 28. So after 1 hour, it's now 28 miles from the ocean. After 2 hours, how far is it from the ocean? 24. After 3 hours, how far? 20. What is my pattern? It's going down by 4. It's traveling 4 miles per hour. Right? 4 miles per hour. So could I assume 4 miles per hour, which is my time, equals my total miles, correct? That's how I come up with that equation. Divide both sides by 4. My time equals 8 hours. Now, I didn't show the last class that equation because I was hoping that they would just use the pattern. However, it led to a lot of confusion. So I use the pattern that I see here in my outputs to figure out how far per hour, 4 miles an hour equals 32 miles total. What if it went 8 miles an hour? What would I plug in here? An 8. 8 times t equals 32, my total. That's how I come up with it. Or, and this is what I told the last class, just keep counting. If after 4 hours it's 16 miles from the ocean, 5 is 12, 6 is 8, 7 is 4, and 8 is 0. Now it's at the ocean after 8 hours. Okay? Again, the only thing you really need to take from this example is that we're using a pattern here in our output to predict the future, to predict some type of answer, some type of result. That's it. Example 3, we're graphing a linear equation. The directions on this section, this is for 16, 18, 20, and 22. Here's what it says. Graph the equation. You can't graph an equation without ordered pairs. It doesn't give you any. However, you can come up with your own. Now, I taught you on Friday to use a standard set of numbers. Does anybody remember?
Yes.
What is it? Say it with me. No. -2, -1, 0, 1, 2. Okay? Most of the time, that is going to be the domain. What is domain? It's my x values that I'm going to use. Okay? Most of the time. There's only one exception to that. We'll talk about it in a minute. So now that I have my standard set of numbers, I'm just going to use those numbers. What do I do with those numbers? What do I do? I plug them into the equation. This is the part you do not have to show work on your homework. You can do it straight on your calculator. Plug in -2 in for x. What is 2 times -2 minus 1? You should have it in your notes from Friday.
It is
-5, then what? -3, then what? -1. Now at this point, I can see a pattern. What is my pattern? To increase by 2, so you could just fill in the rest, 1 and 3. Once you find your pattern, you can fill in the rest of your table. All right, and then we'll talk about the next step in just a second. For now, let's go to the next problem, and let's fill in our input-output table. Again, we use our standard set of domain numbers, -2, -1, 0, 1, and 2. I want you now to do your outputs. Fill in your outputs for that table. If I plug in -2, what's 3 times -2? -6, then what? -3, 0, 3, 6. And again, I see a pattern. So if you've got one that's just totally out there, that's an indicator to you before you graph anything, go back and fix that. Figure out where you went wrong. Okay, it might just be a little typo you put in. All right, now let's look at this last equation right here. Y equals 1/3 x plus 1. What do you see that's different about this equation?
Fraction.
It's a fraction. So whenever you have a fraction, look at the number in your denominator. We see a number what? 3. Your input values need to be multiples of 3. It has to be a combination of 2 negative numbers, 0, I like 0, and 2 positive numbers. So name me some multiples of 3. -6, -3. What about -36? Don't you want to use that one?
No.
Why not? That's too big. I'm going to have a huge output. I don't want to output a 13 or negative whatever. It's going to be -12. Okay? So I keep them small. I keep them tight around 0. All right? My multiples of 3, -6, -3, 0, 3, and 6. This will ensure that I have a whole number for my output. Who wants to graph decimals? Not me. Okay, that's not fun. I want to graph whole numbers. So whatever your denominator is, you use a multiple of that number. Go ahead and fill in the rest of your input-output table. Okay, first output value. Do you have it? -1. Then what? 0, 1, 2, 3. Okay, if you haven't finished filling it in, go ahead and fill it in. And go ahead and get out a sheet of graph paper. Okay, fold it in half and then in half again. We're doing 2 graphs today. 2 graphs. While you're setting up your graph papers, I want you to listen to this before I go to the next screen. All right, you have now 3 sets of ordered pairs that you can graph. Do you see that? You've got your x, y values. So look at the first table. You've got 1 ordered pair, 2, 3, 4, 5 sets of ordered pairs. Do you see that? We are now going to take those sets of ordered pairs and we're going to graph it. Now, instead of making you do 3 graphs, we're going to graph the very first equation, and just know that your other 2 equations you would graph the same way. Can we all agree? Without having to do all 3 graphs? So we're going to graph the first one, but if we were to graph all 3, they would all look very similar, except they would just have different sloped lines. The lines would just look a little bit different. All right, so here's how you need to set up your graphs. All right, from your point of origin. From your point of origin, you need to skip a block. Whoops. You need to skip a block and label your 2. Skip a block, label your 4. Skip 1, label your 6. Make sure you're skipping blocks, because what value does that very first block represent? 1. Okay, so you got to skip it. Don't skip 2. Skip 1 block. Every other block, 2, 4, 6, 8. Go ahead and number them. So now go back to your ordered pairs. Okay, your first ordered pair, -2, -5. So you come over, you come over here to your graph, all right, and you plot your first point at -2 down 5. Then you plot your second point where? -1 down 3. Go ahead and plot your last 3 points. All right, so 0, -1, 1, 1, 2, 3. Draw your arrow, your line, and your arrows on the end. The arrows on the end mean that there are infinite numbers of solutions. The ordered pairs that are solution to this equation extend on into infinity. These are just the 5 that I have plotted. The last step is to write the equation that we have graphed on our graph. So when they're checking your paper tomorrow, they can see, oh, this is the equation y equals 2x minus 1 that they graphed. Okay, y equals 2x minus 1. Yes, Jonathan?
Do you need to label the points?
You do not have to label the points. That's a very good question. All I want is just the points. Your label on these is actually to write the equation on the graph that you graphed. The question was just brought up on this particular section on your homework. It says, tell whether it's a function. This is a function, and here's why. Because every input has exactly 1 output. That's the criteria for a function. So either on your graph or on your regular paper, you just need to tell me, yes, function. Okay? Yeah, this is a function. There's really only one scenario where it is not going to be a function. We're going to talk about that in just a second. Okay, so now in example 4, I'm graphing vertical and horizontal lines. Okay? I'm going to graph a vertical and a horizontal line. Well, and this is going to be on your second graph. Here, is there any math that needs to be done?
No.
Y equals 3. That's it. Y equals 3. All right, and then same thing with x equals -2. Any math that needs to be done?
No.
All right, so on your second graph, we are going to graph these lines. Vertical. Okay, do you have your second graph numbered yet?
No.
All right, go ahead and number them. Okay, my first equation was y equals 3. Y equals 3. So I'm going to plot a point on a y value of 3. That's it. It just says y equals 3, so I plot my point on the 3 on the y-axis. And here's how I want you to remember this. If it gives you a y value, y equals 3, you're going to draw your line in the opposite direction of the axis. So since I'm on the y-axis, my line is going to go opposite, horizontal. Okay? All right? So since my point is on the y-axis, my line goes in the opposite direction horizontally. I just plotted, so I'm going to write in purple, y equals 3. Now I want you to get out a different color pen or pencil. You are not going to do this on your homework. Every graph has to be on a separate graph. But for today's sake, on our notes, we're going to do 2 lines on one graph. Okay, so just do a different color to represent that line. Now we're going to plot. What's our second one? Was it -2?
Yeah.
X equals -2. So where would I plot my point? On an x value of -2. X value of -2. And again, since I plotted on the x-axis, which way does my line go?
And the y-axis.
Straight up and down, vertically. All right, and here's what you need to know about horizontal and vertical lines. Do you remember when we learned about the vertical line test in the last section?
Yes.
Okay, the vertical line test says I can draw a vertical line through any point on the line, and it should only pass it one time. You remember that? Okay, so vertical line test, I can draw my arrow here, on my purple line here, here. Yes, it passes my vertical line test with flying colors. So y equals 3 is a function. Yes, it is a function. Okay? Now, for x equals -2, is it a function? Does it pass the vertical line test? No, it fails it miserably. It is a vertical line. It hits this point, this line, on every single possible point. A vertical line is not a function. Not a function. So the only problems on tonight's homework that you will say are not a function are the ones where you graph a vertical line. And you just, the ones where it gives you an x value. So if it says x equals 4, you automatically know, not a function. X equals 1, not a function. Just graph it on the x, vertical line, and you're done. There's no table. You don't have to do an input-output table for these. All you do is you plot the line and you say whether or not it's a function. Last example. So in example 5 now, we have equations, but the problem with these equations is they are not written in function form. Function form is y equals mx plus b. Write it in your notes. Y equals mx plus b. Okay? Bunch of variables. You don't have to know what they all mean just yet. But what variables do you see that are important? Y and x. M stands for your slope. That's just a number that's going to be attached to x. B is your y-intercept. But again, that one's not important yet either. Y equals mx plus b. Here's what has to happen. Y has to be by itself on one side of the equation before you can do your input-output table. So you cannot just look at this and say, okay, I'm ready to do my table, so here's my x and my y value, and I'm good to go. You cannot start it yet because this equation is not in function form. So again, my ultimate goal is to get y by itself, so I'm going to follow my rules for a 2-step equation. I have to first move the term that is not connected to my variable that I'm solving for. X. I've got to move my x term first. So how do I move x to the other side? Since it's positive, I do what? Subtract it. I subtract x from both sides of the equation. Now my x's cancel on the left side, which is my goal. But they didn't just disappear. I moved it to the other side. And now I'm left with 2y equals, now here's the question. If I'm writing it in function form, look up here at the equation, okay? Which term comes first, my x term or my number by itself? No, which term comes first? Your x. So when I'm trying to choose which one of these terms comes first, I always write my x term first with its sign. So that's why I write negative x. Is it plus 6 or minus 6?
Minus 6?
Is it positive or negative in the original? It's positive, so it's plus 6. It's still not by itself. I have to divide everything by whatever number is connected to y. In this case, 2. So now when I divide everything by 2, my y, it cancels out. My y is by itself. What number do I know is understood in front of the negative x? A 1. So I'm going to put it in there. Negative 1/2 x. What's 6 divided by 2?
3.
Plus 3. And now my equation is in function form. Now I can do, which I'm not going to fully do this step because we're running low on time, but now I can do my input-output table. What input-output values are you going to use? No. What input values am I going to use? What number? Nope. What number is in my denominator? 2. Multiples of 2, negative 4, negative 2, 0, 2, 4. So now that it's in function form, do your table, do your graph. You have 4 of these on your homework tonight. 3 steps, function form, do your table, do your graph, which we just did in example 3. We're not going to repeat because we've already learned how to do that part. Okay, now, whoops. Okay, now I want to, my 3 disappeared. I want to do another one, just like this. Write this equation in function form. Okay, I want you to think a minute. Try to do the first step on your own. Just want to give you just a sec to try to think ahead. What do we do first?
Minus 2x.
No, we're just going through it together. You're not supposed to be solving it totally on your own. You subtract 2x from both sides. Subtract 2x. We're not dividing anything. Now what are we left with on the left side? Negative 3y equals, now which term do we write first? The 3 or the negative 2x? Negative 2x. My x term comes first, negative 2x plus 3. But I'm not done because I still have something connected to y. What do I have to divide everything by? Negative 3. Now that that cancels, I have to simplify what's on the right side. What's negative 2 divided by negative 3?
Negative 6.
Nope. Positive. A negative divided by a negative is a positive. So y equals 2/3. And now what's 3 divided by negative 3?
Negative 1.
Negative 1. I'm not subtracting, I'm dividing. Minus 1. Now what do I do with this information? If I was doing this homework problem, now that it's in function form, what do? Input, output table. What numbers, think for a minute, what numbers are you going to use?
Negative 6, negative 3, 0.
Hayden, you with me? What numbers am I going to use? Negative 6, negative 3, 0, 3, 6. Okay, whatever is in my denominator, I use multiples of that number. I need 2 negatives. I keep it nice and tight around 0. All right, we're just going to do one more of these, maybe 2. Another one in function form. All right, whoops. Hold on, let me back it up. All right, go 3x plus 6y equals 12. I want everybody to do this one start to finish, and we'll go over it. Okay, what do I do first? Walk me through it. What do I do first? Subtract 3x. What is my equation when I rewrite? 6y negative 3x plus 12. Did you write it in that order?
Yes.
Okay, now what do? Divide everything by 6. What's connected to y? Okay, so now ultimate goal accomplished, y equals, okay, what is negative 3 over 6 reduced? Negative 1/2 x, what's 12 over 6?
2.
Plus 2. Okay, now I can set up my input-output table, and what domain am I going to use?
Negative 4, negative 2, 0, negative 2,
Yes.
4.
Negative 4, negative 2, 0, 2, 4, because I want to use multiples of 2, so I cancel out my fraction. Don't forget about your negative. All right, like I said, on your homework tonight, function form, table, graph, 3 steps, 4 problems. If you understand that, that's everything you need to know for 8.2. Deep breath.